Simulators also, they will define the different concept only. Okay, this is the matrix representation and introduction of the robot mechanics. MEM School of Engineering, Department of Mechatronics Engineering, online classes, subject robot machine vision systems, unit number 3, robot mechanics, unit number 3. So robot mechanics. So last class we discussed about basics of robot mechanics. That is what is forward kinematics, what is inverse kinematics, then how to represent the robot in a matrix representation, like that we discussed. Now in this chapter we are going to discuss about homogeneous transformation matrix. That means if you are transfer the some end effector with the different position, that is rotary and the translation concepts. Okay, that is a transformation matrix must be in square form. It is much easier to calculate the inverse of square matrix. To multiply two matrices, the dimensions must match. Yeah, this is the basic homogeneous transformation concept. The function will be like that. So last we discussed about like this. So there are three types of transformation. So the transformation is defined as making a movement in a space. How the end effector will be movement in the space. So the type of transformations are a pure translation, a pure rotation, a combination of translation and rotation. Okay, this is the concept. So representation of a pure translation. Okay, if a frame moves in a space without any change its orientation. Okay, so in this concept, so there is no change in the space, only translation, because A actually with the same concept, same vector, but it will only move with the distance of D. Okay, but we can write as Ax 0, remaining values as y 0, because it will represent A value will be with the x only. So remaining value will be 0. Same as here 0 1 0 0, same as here 0 0 1 0. So position of the new position. Now this is a new position, that is dx dy dz. So scaling factor d also connected with the origin. So we can put the scale factor as the 1. So this is the concept we have used in the okay space. So this is a concept. This is the one of the example for pure translation. A frame F has been moved to 10 units along with y-axis and 5 units along with the z-axis of the frame. Find the new location of the frame. So this type of sums will be shown in the unit exams. There is an example value they give, that is f. Okay, f is a function of values they give. So here what the change, that is translation of x-axis will be 0. So only they are putting the 0 value. So translation of 10 of the y-axis and the translation of 5 units of the z-axis. So you have to multiply with this value. Get dx, dy and dz value will like this 0, 1, 0, 5 into 1. If you are multiplying means you will get this answer. It is a simple concept. If you are going to translate the one frame to another frame means it is very easy. Okay, because if how much it will be translation like that means you have to define the matrix for translation. You can multiply with the existing function. Next one is pure rotation about an axis. Pure rotation about an axis. So the frame is at the origin of the reference frame and parallel to it. Okay, here same conditions, but it will move to the particular angle. That is, there is no translation, only rotational. So it will take some angle with the main axis. So this is the before rotation. This is after rotation. Okay. So rotations are defined with the theta. Okay. Already we know that Pythagoras theorem. Using the Pythagoras theorem, we can define the nx, ny, az like that. We give it the values. So we can get the values of r OT. That is rotation of z comma theta. So rotation of a axis with the z. So like that we have. Okay, this is a common. So this is a dx, dy, dz. Here there is no translation, only rotation. So only we are putting the values as 0. So scaling factor will be 1 always for this one. You no need to change for the any conditions. So here you are using the a z. So only here we are putting. So y means we are putting here. X means we are putting. So y means we are putting the 1 in this concept. Using Pythagoras theorem, we can define the cos theta and sin theta like that. This is the position representation of the robot in the forward kinematics. Okay, this is a combination of transformation. So that is combined transformation of consist of number of successive translation and rotations about fixed reference frame. That is both translation and rotation will be happen in the concept. The order of matrices written is the position of the order of transformations performed. If order of matrices changes, the final position of robot also changed. Say example. So this is the example of a point P731 is attached to the frame and subject to following transformations. So find the coordinate of point relative to reference frames. Okay, in this we have a different condition. Rotation of 90 degree about z-axis followed by rotation of 90 degree with y-axis, then followed by translation of 4 in x-axis, minus 3 in y-axis, 7 in z-axis. So this is the concept. Here we have a equation depend on the given consideration. So translation, rotation and rotation. So always first we need to define the translation concept. Okay, here they gave the total values. You have to multiply with this. Okay, translation we can put like this 1 1 1 4 minus 3 7 and 1. Okay, because already we know that for this one, for this translation we can get like this. For rotation y of 90 already we have sin theta and cos theta values. You have to define the theta value as a 90. Okay, for this sin and theta we can get the values 1 or minus 1. So this is the rotation of z comma 90. Then the unit vector. So that is given position. So that is p of 731. So that is given in the concept. You have to multiply all these value in the matrix format, then you will get the answer 5 4 10. This is the final concept. Same as we can use the different process, that is after the first transformation, after the second transformation, after the third transformation. It depend on the given sums. Okay, these are the homogeneous transformation of the robot. That is, there are two transformation. One is translation, another one is rotation. So translation depend on the distance. So you have to calculate, measure the distance of x, distance of y, distance of z. Okay. So in second one, that is rotational, depend on the what? Depend on the theta with the main axis. So you need to define the cos theta, sin theta value using the Pythagoras. So in third one, we are combining the total translation and the rotation. So you need to define the both concept. You have to combine. There is no complication in the process. You just combine and you just multiply with the original data with the position. That's all. You'll get the answer. Okay, this is the homogeneous transformation of the forward and